Hello everyone, welcome back to One Stop Academy with Alison. Today's tutorial is on problem solving and algorithms part 2. So we previously uploaded a video on problem solving and algorithms with an introduction of what algorithms are all about. So today we are going a step further to explain problem solving and algorithms and some terms related to algorithms. So this tutorial is going to cover a number of items, the first one being the origin of the word algorithm. So to understand what a word or a concept is about, you have to know how the word started. So if you are able to know that, then it can give you a better understanding of what the concept is. We're also going to see the introduction and definition of some terms that we cannot do without while talking about algorithms. Terms such as variables, data types, mathematical operators, keywords, statements, and some others. We'll also look at statements, on the different kinds of statements, and examples. Algorithms can be represented in certain ways. What are those ways? We're going to see them. And then we're going to look at the pseudocode, definition, properties, and examples, and something for you to try out. First of all, the origin of the word algorithm. So it turns out that the word algorithm dates back to 900 years ago. That is about 9 centuries ago. According to popular sources, it's an eponym of the name of an influential 9th century scholar who was also an astronomer and mathematician called Muhammad ibn Musa al-Khwarizmi. Pardon me if I don't get the pronunciations right, but I think I tried a bit. So he was a popular mathematician who contributed to mathematics in the 9th century, and his name can also be traced to the origin of some other words such as algebra. And this eponym was translated from Persian to Latin and then finally to English, to what we have today as the word algorithm. Like I said earlier, there are some terms that we cannot do without while talking about algorithms. Terms such as variables, data types, mathematical operators, keywords, and statements. We're going to look at them right now. First of all, variables. So simply put, a variable is an area of memory that stores one item of data. So you can think about a variable like a box, right? And that box can only contain one item, one kind of item at a time. So have that picture while we discuss variables. Well, in maths, you can think of a variable as a value that can change over time. So looking at the equation we have here, 3y minus 12 equals to 0. And then if you simplify further, carrying minus 12 over to this side, we have 3y equal to 12. And then dividing both sides by 3 will give us the value of y as 4. I'm sorry if you ever went out through the window during your maths class. I'm sorry, you have to hold on. I always tell my students that mathematics is the basis of understanding how computers work. So you cannot do without it if you're in the world of computers. You just have to try to grab as much as you can so that you can get along well with the subject. So y in this case is a variable that has the value of 4. Also, another equation, 5y equals 12 minus y. Y is the same variable. Simplifying further, we have 5y plus y equals to 12. That is, if this minus y moves over to this side. And then 5y plus y will give us 6y equals to 12. And then dividing both sides by 6 will give us y is equal to 2. Now, this is also the same variable y, but with another value 2. So for the first equation, the value of the variable y is 4, and for the second equation, the value of the variable y is 2. You can see that the value changed given different parameters. And then in programming, A variable is assigned a value that can change based on information passed on to it by a program. This is obviously similar to the explanation in mathematics. Looking at what we have here, y is assigned the value of 10. This backwards arrow means it's an assignment symbol. We're going to look at that when we talk about statements. So this right here means y takes the value 10. So you imagine that box, that empty box. You're putting the value 10 into the empty box. That means nothing else can go in. 10 has taken the space for the variable y, or for the box y. It also means that y is assigned 10. Also, the value of the variable can be increased or decreased. Looking at the expression we have here, it means increase the value of y by 2. That is why we have y plus 2. So whatever the value of y is, increase it by 2. So if y had the value 10, you're going to add 2 to 10 to make y have the value 12. So imagine the box again. There was 10 in the box, and then you're going to add 2 into the box to make it 12. It's still the same variable y, it's still the same box. Also, new variable values can be created from old ones. So looking at this expression here, it means y takes the value p, or y is assigned the value of p. This means there is a variable y and there is a variable p, right? So imagine two boxes. Now y has its content and p has its content. So imagine taking the value or taking the content of p and putting it into y. That is what this expression here means. The next concept is data types. So a data type is a set containing values and operations that can be performed on those values. Yeah, so it's a set containing values, and that same set also contains operations that can be performed on those values. Basically, a data type tells the computer how to treat the values of a variable. So imagine a data type like we have that box, right, which is for the variable. So we have some items in the box. Imagine that the box is for a kid. A kid opens the box and sees an item in it. So the kid doesn't know if that item is edible, or if he's supposed to play with the item, or if he's supposed to throw the item away, or if the item is dangerous. So these are all different kinds of items and different things that the kid might want to do with what he or she sees in that box. That is what a data type does too. So a variable can take a value, and another variable can take another kind of value, right? So a data type tells the computer how to treat the values of a variable. There are some common data types which are sort of universal, such as integer, which are whole numbers, floating point numbers, which are fractions, decimals, characters, strings, boolean, and arrays. And then a further classification of data types will have primitive and non-primitive data types. Non-primitive data types are also called composite data types. On to mathematical operators. So mathematical operators basically enable easy manipulation of stored values. So you have values, right? How do you manipulate these values? With what do you manipulate these values? There are common operators like the assignment operator, which we saw when I was trying to explain variables, right? So this is the assignment operator, the backwards arrow. You could also use this symbol. There are also comparison operators for comparing values, including the equals, not equals, greater than, less than, greater than or equals to, less than or equals to. So we also have arithmetic operators, which are very common: plus, minus, multiplication, division, modular arithmetic, and then the logical operators. Next on the list is keywords. As its name implies, a keyword is a reserved word. When writing algorithms, keywords are used to indicate common inputs and outputs and processing operations. When the computer sees a keyword, it knows that keyword is for execution. How to identify a keyword in an algorithm? Usually it appears in capital letter, while the rest of the program or algorithm appears in small letters. So, and they include start, input, output, print, if, else, while, set, store, and a host of others. A statement is a part of a program or a pseudocode. A statement indicates a particular action to be performed in a program. You can simply say it's a command given to a computer. Now let's look at this example to see how statements work. This is the first algorithm, and the first statement says add 3 to 2. You can see that add is a keyword which is implying a particular thing for the computer to do. So the computer is supposed to add 3 to 2. And then on another line, the computer is supposed to print I am ready for business. This is a string of characters. The computer is supposed to print this, that is output. When you see the keyword print, it means display for the user to see. So the computer is supposed to display this string I'm ready for business for the user to see. Now the first one is an example of a statement, right? It is indicating a particular action to be performed. The second one is another statement, also indicating another particular action to be performed, right? Just like in English language, how statements work in the English language. There are different kinds of statements depending on what kind of function you want the computer to perform. There are declarative statements, assignment statements, conditional statements, and iterative statements. Declarative statements, what they do, they associate a variable name with a type, while assignment statements, what they do is they associate a data value with a variable. Conditional statements are used when different actions are required for different inputs, right? So they evaluate statements and execute instructions based on whether the evaluated statement is true or false. Also, a conditional statement may be applied when the condition is single or when the condition is multiple. For example, the first one we have here, if you are hungry, then eat. That is just one condition required, right? Then for a multiple condition, if you are hungry, then eat, else walk. So the first condition is you're hungry. The second condition is you are not hungry. So for the first one, if you're hungry, the action required is to eat. And on the second side, if you're not hungry, the action required is to walk. So this is what I mean by different actions for different inputs. The input in the first case will be hungry. The action will be eat. Input for the second case, not hungry. The action will be work. And that ends that particular conditional statement. Iterative statements. Iteration involves repetition, right, in the English language. So iterative statements are or an iterative statement is a repetition of a set of instructions to achieve certain desired results. They are otherwise known as loops. Loops is a popular term used to refer to iterative statements. Popular or typical iterative statements include the while loop, the for loop, a for next loop. These vary, how these work vary according to the programming language. Now, algorithm representation. Algorithms can be represented in different ways That is, you can break down a program step by step in different ways, and two of those ways are pseudocode and flowcharts. So a pseudocode is similar to writing a set of instructions in plain language. So you're going to see words and statements and instructions, right? But a flowchart, on the other hand, is a more graphic way of representing algorithms. You're going to see some shapes and arrows connecting the shapes and so on. But this tutorial is going to cover pseudocodes. Pseudocode is basically an informal description of a computer program written in symbolic code. Symbolic code means understandable language, like English, that you're using to communicate. Firstly, a pseudocode is not a programming language. It's usually confused as a programming language, but it is not. It's an algorithm. It's a way of representing an algorithm, and it makes it simple to describe a set of instructions without the use of specific syntax. Remember, it's not a programming language. It's a particular programming language that usually has a syntax. But for the pseudocode, no syntax, just a simple way of expressing a set of instructions. And then each step of a pseudocode is written on a separate line for organization purposes, so that it can be well understood, it can be easily understood. And then after a pseudocode is written, it can then be translated, or it can then be expressed in a particular programming language, and this is what the computer can run. A computer cannot run the pseudocode, but when the pseudocode is expressed in a particular programming language, then the computer can now run it. When writing pseudocode, keywords are written in uppercase, variables are written in lowercase, and messages, also known as outputs, are written in sentence case. So let's look at an example of the pseudocode. The problem here is to accept a user's name and age and print a comment based on the user's input. If you look at the keywords we have here, let's see what some of them mean. The output keyword. Output in this case means to print or display a message or result on the screen for the user to see. The input in this case is to accept data from the user. So you display, the computer tells the user what it needs, and then input is the user giving the computer what it needs. Store in this case is indicating that whatever the user supplies under the input statement, the computer stores. And then you can see the if then conditional statements, also the else, showing multiple conditions. And then end means the pseudocode has come to an end. So let's start from the first statement. The computer requires a name from the user, so it says enter your name please. The second statement, the user enters their name. So if your name is Peter, for example, so the user types in Peter. The computer knows that it should store Peter as the variable name, right? So let's say it chooses to make it short by using the letter P. Then the computer now says enter your age please. So let's say Peter is 12. Peter enters his age 12, and then the computer stores the user's input, which is 12, in the age variable. So there's a variable for the age of the user. Then this statement, if the age is greater than or equal to 40, then the computer should display dear Peter, life begins at 40. But in this case, our user Peter is not up to 40. Peter is 12. So the second condition is else, means if the user's age is not greater than or equal to 40. In this case, the computer or the program should display to Peter, "Dear Peter, you only live once." So that means Peter should make the best of the time he has while he is young, and then the program comes to an end. So this whole code here, this whole pseudocode, can be translated in a particular programming language to be run by a computer. You can see that every statement is on a single line. It's on a line of its own, just for this to make it organized, and then the keywords indicate particular instructions for the computer to execute. And like I said earlier, pseudocode must be translated to a programming language for it to be executable. Okay, so it's your turn to try out something to see if you grabbed the concept of pseudocode. Try to write a pseudocode to accept students' name and score in a test, and supply comments to the user saying if they passed or failed. A hint is that you may choose to set a particular pass mark so that a student either scores above the mark, scores that exact mark, or scores below the mark. So that's enough hint for you to put a pseudocode together. And for us to see your attempts, please leave your codes in the comments section. We would assess them and give you feedback over there. Thank you for watching this tutorial.